Hi guys, here in this section we will be talking about the state machine diagram. Now the one which you are seeing on screen is a state machine diagram for a ticket selling system. Now I will be talking about this and then we will be going to the student course and instructor topic as well while explaining the state machine diagram. But before that we need to know why a state machine diagram is required. Now, remember that state machine diagrams show you that how an object can change from one state to another depending on certain condition or events. Now, think of it like a light switch. In your home, you have a light switch, right? Now, it can be in on or an off state. And you change between these states by flipping the switch off or on, right? So this is a example that how an object change its states, right? So that is what you need to remember, that whenever you are talking about a state diagram, you are talking about the dynamic behavior of a class in response to certain external stimuli. Now when you are clicking on the switch on or off button, then only it will be on or off, right? So it basically describes you the sequence of states that an object goes through during the life cycle or the lifetime and the events because of certain transition from one state to another state. In this diagram you can see available, locked and sold from the ticket viewpoint. Now whether the ticket is available, whether the ticket is locked for booking and then it is sold out is what it is showing in this state diagram. But we will come to this. Before that, we need to know why we model these state diagrams. Just to give you another example, imagine you are designing a video game, okay? Now your character can be different states like running, jumping, or you are standing idle. Now by modeling these states, you can easily design how your character should behave and react to the player inputs. And that is why the modeling the state diagrams is very, very important. Okay, so that is what you have to keep in mind. I mean, there are several reasons. I am not going in all the reasons. Maybe when we talk about the notational components, we can talk about, okay, let me start talking about the notational component. Now states, what, as I said you just now, that in a video game the states can be running, idle, jumping, right? Now these are different condition on a situation and these are called states. Now you can see here initial pseudo state, final state, like that you will get in your own tool and you can just drag. But if you see the state is not really a rectangle, but there is a circle around this rectangle. That is what the states is, unlike that of the activity diagram which we have shown, which we have seen in the last section, right? Now so while modeling this, you need to understand the object behavior and how the object is changing the states. They help in understanding the behavior of the object over time, providing insights of how the object responds to a certain event. Okay, now what is transition then? Now transition is, in case of switch, it is flip the switch, you press the jump button in case of the video games. Now these are the actions or events that causes a change from one state to another, and that is what the transition has been used in this. Also in this particular case you can see that the ticket is there is a starting point, initial pseudo state. From there you are seeing that the ticket is available and it goes to a logged state from there, right? The transition, this is the transition button, it goes to the logged state when you are booking that ticket, right? Now that time this lock state will be one transition. From then when you are putting another transition, it is going to the sold state. So that is another transition of the system. Now you need to identify the states and the transition, and how it will help is they will allow you to identify not only the different state of the object but also the transition between different states. Now this is one state to another state in the with a particular transition. Sorry for this one, I have taken it out, and this is another state. So that is what you need to remember, and this will help you designing a robust system. I mean, whenever you are talking about designing a robust system, you need to understand that the state machine diagrams comes into picture. This will give you an error-free system by ensuring that all the possible states and the transitions are considered. You're not missing out. Now, in the advanced concept, you will see that there is a composite states also. You can get a composite. What is that? Now, think of a TV. Now, it can be again on and off, but when it is on, it can also be in different states, like playing a channel or the menu screen or guide screen, whatever you have, depending upon what kind of screen you have, isn't it? Now, those are called as composite states. So remember that. Now, these composite states can make your life more easier to understand what all the states can that TV have. Okay, then you can think of concurrent state, and concurrent state is another notational component. These are coming in the advanced concept of your state machine diagram. Now imagine a car. It can be moving and playing music at the same time, isn't it? So it is moving and also playing music, so that is the concurrent state. So I'm just giving some real life examples so that you can directly relate rather than showing in this diagram. So I'm not drawing that, but we will go back to the student shortly. Student course and instructor one. Okay. Then there can be guard condition. You need to remember there is a guard condition, which is a constraint kind of things. These are like rules. For example, a door will only transition from a closed to open if it is unlocked. Now, if you are drawing a door, from the closed state to open state is only possible if you are unlocking the door. Otherwise, you cannot come out. Like that, entry and exit actions are there. We have seen the entry and exit action in activity as well. So, similar action that happens when entering or leaving the state. Okay. For example, turning on the light when entering the on state. So when you are turning on a light, you are basically entering an on state from there. So you are transitioning from there to an on state. Okay, I just don't need to draw this. Okay, now if you have to visualize this, we definitely can draw a diagram. Let me think if there is any other concept which I have missed out. I don't think I have missed out anything. Let me draw a very simple one first, so that we will be able to relate the on and off state what we have spoken, and you know how to draw that. And in the next section we will draw that. Okay, now this is a state. Okay, I have chosen the submachine state, that's why it is coming. Just a second. So I just need to go here and I should be able to get that. Sorry, yeah, this is the state one and I don't need this. I was trying to draw a state of on and off. I will come back to this one again. Just let me make it clear. So I'm not writing the submachine state at the moment. I am just creating a state. So one state, and I will create another state. Okay, let me draw it here so that we get some space. Okay, and then you take this one as a starting point. Now say for example this is off and this is on. Okay, now what is happening is how the transition is happening. Your transition start from this start point, you come here, then what you are doing is you are flipping the switch to on, right? Now how to flip the switch to on, that is another transition. Basically you can write what you are doing. So if I write here flip switch, that gives you one condition of it. I can take it this side so that another transition will be you are flipping to, I am doing that, and here I am saying flip switch again. So the moment I say that, it is going to the off state. So this is the initial pseudo state or initial state where you are starting the entry exit position, and then you are either, basically when you are starting you will be in off state, and then you are switching it on, and then you are flipping back to off state. That is what I was telling, the state of the object that will keep on changing. Now in the next section we will quickly see and draw the student, course and instructor, the one which we have spoken. So we will at least see how the student object has enrolled in the course and how the state of that object keeps on changing. And that is the basic idea, that is the basic objective of a state machine diagram. So keeping that in mind, let's move to the next section, and we are good to draw the state machine diagram now. Okay.